All right, now in order to add an element to the list, we have first to decide whether we want to add the element from the back of the list, from the very end of the list, or from the front of the list. So let's say for now that we want to add the element from the front of the list. So it would be something like this. So here we have a struct, this is a list. The head of the list is pointed to null and the size is 0. So if we want to add an element to the list, then we have to create a list node, and every list node has a value. Let's say we want to add the number 9, and the next of that node is null. Okay? It doesn't have a next. Its next is null. Okay? So it's the only node there, or it's the last node there. So after creating the node and making its next to be null and its value to be the value that we want to add here, we have to make the list structure's head points to that node. Okay? So to change this null here with a more general next value, we would change that with the content of the head. So this equals the content of the head. So the head is null, so it takes null. If the head was pointed to another node, then we would point this newly created node to that other node. Okay? Let's say, for example, we want to add another node. So if we want to add another node, then we have to create that other node, put in its value. Let's say its value is 5. So that's 5. Its next would be the content of head. Now head is pointing here. So that node would point also there to that last created node. And then the head would be updated with the newly created node. So the head would be updated to the address of the newly created node. And so on and so forth. So this technique will allow us to add nodes to the left of the list. Okay, always to the head of the list, not to the back, to the front of the list. So let's do this. Let's write all the operations. So the first thing we have to do is to create a list node. We're going to allocate memory for that, for a list node. And then we're going to fill the list node value and the list node next. So the value takes the value parameter from the function, and the next takes the list head. And finally, the list head takes that newly created node. Okay? So basically that's it. So let's write this idea. So it's a function of type void called push front list. So this function will add a value, a number to the list, but to its front, okay? Not to its back, to its front. So it'll take a list pointer, L, and it'll take the value. And the first thing it'll do is it'll create a new node of type list node. So list node pointer ln equals list node pointer, and we use the malloc function to allocate the required storage, the required space for list node structure. Now that we have the list node structure initialized with the required memory, we have to fill its fields. So its next would be, let's fill the value first. So its value would equals to the value from the function, and its next would equal the L head, okay? And then finally, the L head would take the newly created node. All right, cool. And the last thing here, the last thing we need to do after adding an element to the list, we have to not forget to increment the size of the list. So the size gets incremented by 1. Cool. Now the last thing we need to do in order to test our data structure is basically we're going to have to create a function that will pop elements, okay, from the list so that we can print them back and see if the list was able to store elements correctly or not. So removing elements from the list is also pretty straightforward. We want to remove this element, this 5 number from here. If we want to remove that, then basically the first thing we have to do is we have to copy the element's number inside a value variable, integer. Now that we have that number copied, we have to copy the address of this node. So let's save that inside ln variable, list node variable. And then the head would point to the next of ln, so it'll point here, okay? Now our list was fixed. We got our new list without the 5, except that we still have the 5 stored in memory. So we have to free that useless memory. So we're going to free that ln, okay? So it'll get deleted, okay? And we're left off with our list. So let's implement that idea. So that idea, we said the first thing we're going to have to do is we're going to have to copy the value. So let's do that. So value takes the L head value. Okay? Now the list node takes that L head. It takes the address of the node pointed at by head. Now we're going to update the head. So the head will take the next of the node that is pointed at. Cool. And now we have to free that list node ln and decrement the size of the list. And finally return that value that we have extracted in the first place. So let's test this idea. Let's write that code. It's a function that returns an integer, and it'll be called pop front list, which takes a list pointer L and nothing more. Now we said that the first thing that is going to happen is basically we have to declare a variable called value. The value will take the L head value. And then we have to copy the address of the node that the head is pointing at. So list node pointer ln list node takes the L head, and then we update the head with the element next, with the next node of the element that is currently pointing at. And then we're going to free the ln, and then decrement the size, and then return the value. Here's one minor thing that we have to consider. What if we try to pop from the list and the list is empty? So we have to add an exception there. So if the list is empty, then we're going to have to print a message saying that error empty list. And let's return 0. Cool. Now this pop function should do the job. So let's test it out. Let's see first if it's compilable. No, it's compilable. And let's create a list. So that's a list pointer. L equals create list. And let's push front to the list L some number. Let's push 5. Let's push another number, 3. Let's push another number, 8 for example. And now let's keep popping the elements from the list, from the front of the list, and printing them out. So while the list is not empty, while the list L is not empty, we're going to print f some number, and that number is the result of the pop front list of L. And cool, as you can see, the list is working perfectly. So that's, we added 5, 3, and then 8. And then here we popped 8 and 3, and that's 5. Because we're adding to the front and removing from the front, we basically have created something that looks like a stack. But again, of course, we can add to the back, so let's do that.